In a chemical reaction, the concept of limiting reactants plays a crucial role in determining how much product can be formed. A reaction stops when one of the reactants is completely used up, which prevents the reaction from continuing even if other reactants are still present. This reactant, known as the limiting reactant, dictates the maximum amount of product that can be produced in the reaction. For example, imagine you are making sandwiches, and you have a certain amount of bread and ham. If you have enough bread for 4 sandwiches but only enough ham for 2, you can only make 2 sandwiches. In this scenario, the ham is the limiting reactant because it runs out first, limiting the number of sandwiches you can make, regardless of how much bread is left. In a chemical context, consider the reaction between hydrogen and oxygen to form water. The balanced equation for this reaction is shown on the screen. If you have 3 moles of hydrogen and 2 moles of oxygen, hydrogen is the limiting reactant because the reaction requires 2 moles of hydrogen for every mole of oxygen. With 3 moles of hydrogen, you can only fully react with 1.5 moles of oxygen, leaving 0.5 moles of oxygen unreacted. This means the amount of water produced will be based on the hydrogen, the limiting reactant, and you'll get 3 moles of water. The limiting reactant determines the quantity of the product because once it is depleted, no more product can be formed. The other reactant, in this case, oxygen, is in excess and will remain unreacted. Understanding the concept of limiting reactants is essential for accurately predicting the amounts of products in chemical reactions, as it highlights the importance of the reactant that is in shortest supply. This concept is widely applied in various fields of chemistry, from industrial production processes to laboratory experiments, ensuring that resources are used efficiently and reactions proceed as planned.